Okay, for today's assignment, we're going to first look at the answers for the right section of it, all but vocabulary. Number one is a way to represent equations algebraically that makes it more efficient to recognize the independent and dependent variables. That is what we call function notation. So let me try to fit that in there. Function notation. So what that means is something that looks like this. F of x equals 2x plus 3, where x is the independent and the f of x is then dependent off of that. So x is what you need to know. When you plug that in, then in return you get the dependent. Number two, when both independent and independent and dependent variables of a function increase across the entire domain, this function is called, well, the keyword was increase across the entire domain. This is called an increasing function. So what that means is something that is just increasing, a line, a curve like that, that is all increasing. So we've done that one, we've done that one. A function has a blank if there's a point on its graph that has a y-coordinate that is greater than the y-coordinates of any other point on that graph. So it's greater than everything. That is called a maximum, an absolute, more specifically, maximum. What that would look like is where you'd have a graph that looks like this, maybe an absolute value like that. These are maximums up here. There's a whole bunch of other examples. Okay. When the dependent variable of a function decreases as the independent variable increases across the entire domain, this is what we call then a decreasing function. So that is going down. It could be a curve that is also, say, decreasing like that. Number five, if the dependent variable function does not change or remains constant over the entire domain, and that is what we call a constant function. And what that means then is you are looking at a horizontal. Okay, that's a constant function. And then lastly, a function, if there's a point on its graph that has y-coordinate that is less than all the y-coordinates, that is called a minimum, or more specifically, an absolute minimum. So something like this, or like this. Those are some obvious ones, okay? All right, let's see. I asked you to review 1A. So on the review there, identify the axis of symmetry for each graph has, if any, and identify the number of quadrants it passes through. So letter A, it does have an axis of symmetry. This is what we call a quadratic graph. And where could you go through and draw a axis of symmetry so that you could fold the left onto the right? It would mirror one another right here. Okay, do my best to kind of put that right in the middle, but it's vertically right there. That's my axis of symmetry, okay? Identify the quadrants. It is in all four quadrants. 1, 2, 3, and 4. Okay, so don't forget your quadrants. This is 1, 2, 3, and 4. Okay. Number 2 is old stuff. Now, number 2 is solving an equation again. And depending on how your equation skills are, I have a feeling some of you are going to need some practice with equation skills. So in this regard, first thing I notice is we have parentheses. To get rid of parentheses, we use our distributive property. 18n and 2 times negative 6 is negative 12. Right-hand side, we have parentheses. So we distribute. Okay, from there on the left-hand side, negative 12 and 52. And what might be helpful for some of you guys, especially if you're struggling with equations, I put sometimes when I'm teaching it, a line down the middle to separate the left from the right so that we can kind of keep things balanced. And negative 12 and 52 are like terms. So I can bring those together. Watch your signs. Negative 12 plus 52 is 40. And this is, again, all review from 7th and 8th grade. But we do know sometimes you struggle there. Now I have variables on both sides, 18n and 14n. Myself, I just typically move the smaller variable, which in this case is 14n. So if it's a positive 14, the inverse of positive 14 is, I'm going to subtract 14n to both sides. 18n minus 14n is 4n. Okay, we move the n's to the left, kick everything else to the right. Next thing I'm going to do is move that 40. So if it's a positive 40, the inverse of positive 40 is minus 40. Bring that down a little bit. 16 minus 40, watch your signs. Use a calculator if you need to. And then lastly, divide by 4. That 4 is attached through multiplication, and the inverse of multiplication is then division. So you should get n to be 6. Now the last one there, number 3, it's not an equation, it's what we call an expression. Somebody tells you that the values of x is 8 and the y is negative 2. So any place we see x is 8, we're going to plug in that. And any place I see y, I'm going to replace y as negative 2. Now after that, it is your order of operations that you guys started learning back in, probably about 5th grade there. Okay, I've got exponents. 8 squared, 8 squared, 8 squared. 8 times 8 is 64. So I'm going to do these in steps. 3 times 64. Minus 8, because inside the parentheses there, I have negative 2 plus 2. Negative 2 plus 2 now is 0. And in the denominator, 2 times negative 2 is negative 4. Okay, 3 times 64 now. 3 times 64 is a little of a large number. That gives me 192. And then I have 8 times 0. 0 times anything is, well, 0. 192 minus 0 is still 192. And 192 divided by negative 4. Watch your negatives. So 192 divided by negative 4 is negative 48. Again, 2 and 3 are reviews, starting back to about 5th, 6th, 7th, 8th grade. But I have a feeling that's where some of us are going to need some more practice.